Remember, with Renaissance, going green saves you money. Hello again, this is Rick Friedrich from Renaissance Charge. Today we're going to talk about our second product, the RC-1AU, and just go over all the details of what it can do and so forth. This is our second charger that we've made. It's about 5 years old. The first charger was a 12-volt charger, and this is our universal charger. What this charger allows you to do is charge batteries that are 1.2 volts all the way up to 24-volt batteries. So we have a variety of batteries here on display, and we're going to go through how you charge them up and just what this can do. So let's go over some details. The battery charger comes with several items. One is the user manual, and we'll go over some of that. The charger itself. Then it comes with a cord that has alligator clips on it. A positive and a negative. This allows you to clip on the ends of battery terminals. And it also comes with magnets. And we'll see how they can be used to charge, to help keep the clips attached to the posts. Just like that. So we'll go over that in a minute. It also comes with a power cord. If it's in the USA. If it's in another country besides the US or Canada, then it will not be supplied with a power cord because they're so different. So let's go over the charger itself. It comes with 8 power functions, power levels. 1, 2, 3, 4, 5, 6, 7, 8, 9, or 8. 1 to 8 settings. And then it has an LED on the front. This is going to indicate whether it's charging, whether there's an error, whether it's charged, or whether it's floating, as is displayed on the front label here. On the top you'll see a chart where you have the basic recommendations for the various power levels. What kind of batteries? We have nickel cadmium batteries, nickel metal hydrate batteries, and lead acid batteries. Just as a sample of the recommended power levels you want to switch this to for the size of batteries. So for example, in power level 1 you want to work with very small batteries. For example, these are nickel cadmium batteries, and so NiCd is nickel cadmium. And you can do 2 AAA batteries or 2 AA batteries, which these would be AAA batteries, or 4 AAA batteries, or a 9-volt battery can be charged at level 1. So if you're going up to level 2, you could maybe charge 4 of these AA batteries, or 2 C-cell batteries, which would be like this. So we'll go over demonstrating these in a minute. Now this particular battery would be a nickel metal hydrate. So that we would find out in the third or the middle column. Now lead acid batteries, which you see at the back there in the corner, those would be indicated right here. So for example, the highest battery we'd want to charge at 24 volts. If we had 2 12-volt batteries in series with each other, you could charge up to 7 amp hour batteries in a reasonable amount of time with this charger on power level number 8. Now, there's no indication here of lithium batteries because lithium batteries pose a certain problem. They have internal regulators inside of them that are very voltage specific, and these often are they interfere with this charging process that they filter it out. So we don't recommend really charging with lithium batteries. Some have done that successfully. Some have charged lithium batteries at bypassing the internal regulator. But we recommend you to be very careful with charging lithium batteries because they can explode, usually only under load, but they also can be damaged. It's very easy to swell a lithium battery and overcharge it. This particular battery charger will keep pushing the battery as much as it can. So lithium are not really made to do that, whereas these batteries, the nickel cadmium, nickel metal hydrate, and the lead acid can do that. This is a universal charger. It can charge any type of battery. It's just you have to be careful how that is regulated. So let's turn it around and look at the back. You'll see the model number again is the RC-1AU-120. So this is capable of, it comes in two different models. The 120 volt model for North America and 240 volt models as well. So we have two different models for this charger. It looks exactly the same, the 240 model as this. It just it requires a different plug. But internally it's different because it's set up for the 220 and it cannot be changed from one to the other. It comes with a basic on and off switch here at the back, which is also a circuit breaker. Also, it comes with another circuit breaker for the AC side. This switch is for the DC side. 3 amp circuit breaker, and then we can plug this port into here to be able to charge our batteries with this. The final thing to look at is this button right here. This is direct DC. So say you have a battery, like a nickel cadmium battery for example, often discharge themselves to 0. They self-discharge. So often this charger will be placed on these batteries, and what will happen is it will be dead zero. So the battery charger does not want to start when it sees 0 on a battery. So if we go and connect up, say for example, to this battery pack, and it's at 0, then what will happen is it will just flash, the LED will flash red. And that will indicate that there's no battery present. No, it does not notice a battery. So we have to press this button, hold it for a few seconds maybe. No longer than 30 seconds do you want to hold this button. And that will put a basic charge into the battery, and hopefully that will be enough to allow it to start. For most other batteries though, you have some kind of voltage that's at least 1 volt. And this battery charger will recognize that, and the safety features will allow it to turn it on. This has reverse polarity protection as well, so that if you do happen to put it on the wrong side, the red LED will flash, indicating there's an error, there's a problem. So that's the basic functionality of this charger. Let's go, before we demonstrate this, let's talk about our customers and the craftsmanship that goes into this. We've had this battery charger, which is really not just a battery charger, it's a Rejuvenator. It allows you to not only charge these batteries and charge and get more out of them at any particular given charge than most other battery chargers, but it also tends to restore useless batteries. So for example, here's an old battery and a power tool that has been sitting for many years unused, and we can still charge this battery up and use this drill. Now everybody's got some kind of power tool in their attic or garage that is no longer able to be charged. You're no longer able to find the battery, a replacement battery pack maybe for it, and so it's useless to you. But now you can actually restore most of those batteries and use those tools again. So what our customers have been doing for almost 5 years using this charger they've been able to not only restore batteries that were being discarded and power tools unused, they're also able to keep their batteries going indefinitely. So some of our customers have given us testimonies that we've included on our website where people have used this charger. For example, this testimony here. My manufacturing company has been using the RC-1AU for our 5-year-old 14.4 volt cordless drill batteries. 6 out of 8 batteries are performing like new. The $320 charger saved me over $600 in new batteries. So the RC-1AU charger is the only charger I allow my employees to use on any battery. So what happens is our customers find that this charger generally brings back 7 or 8 out of 10 batteries, and they enjoy using this product. So here's another testimonial that we've had kicking around for a couple of years from a fire department in California, where they have appreciated using the charger, and it has benefited them. Locally, we have customers too as well that have restored many batteries for the police department here locally. So let's look at running this. Let's go into charging some batteries. So we're going to plug in this on the back here into the back. Now you can see how it's plugged in. And then we are going to turn it on with this switch. It's going to turn up. Let's look at a voltmeter. And see what kind of voltage we have on these batteries. There's 2.4 volts on this battery. So if we turn the switch on, starting at, I think we have 2 of these batteries in series with each other. So right away it goes up to 3 volts, 3.2, 3.7, 4 volts. Actually, this then indicates that all 4 batteries are in series with each other. They're 1.2 volt batteries. So 4.6 volts is the resting voltage. 4.2 volts is the resting voltage. Under charge it's going to be slightly higher, and we're registering 5.4 volts. So this will go and charge the battery for a preset amount of time, and then it will check against the voltage that it initially started with, and if it has gained any in the charging, it will continue. If it remains the same, it will stop, and that's how it indicates how to turn it off. But it will go out for at least 15 minutes and charge the batteries. So that's that battery. So if we turn this off, we can see the battery is resting at about 5.2 volts, coming down a little bit, and if we power a load with it, it will draw it out. So we're going to look at a couple of other batteries here. Let's move this away. Let's look at this battery here. We've already indicated this has a bad cell. One of the batteries is bad. So if we look at this, there may not be any voltage on it. 1.9 volts. So now we're going to use these magnets, because these magnets usually attach to the contacts. the surfaces. And you can use other magnets, but we advise you to use these ones. Otherwise they get too powerful and they can hurt you. Be careful with neomagnets because they can splinter and they can injure you. So we're looking at this side usually is indicated by the positive. And so we can just connect up like this. Let me pull this cord apart a little bit. And this makes it easier than having to use some kind of adapter to plug into every different configuration. Now you want to make secure connections here. If you use two small magnets, which I've done in the past, I found that you can create arcing and sparking here and ruin the battery itself and maybe damage these contacts. So let's put this battery away and let's look at running this. Now what we have here is about C-size type of batteries. And let's go ahead and try to charge this up on power level number 1. Again, let's look at the voltage. And I can actually put the voltmeter inside of these contacts. So 1.9 immediately going up to 2.4, 2.5 volts. One of the cells in here is damaged, so it's not going to take a charge properly. In that case, sometimes after repeated charging it will come back, say on the 10th cycle. We've seen some batteries come back. Other than that, sometimes what happens is over the years the battery chemical will ooze out and short out, and you can't do anything about that. They do need to be replaced in those cases. But you can see here, if we turn up the power intensity, you can hear a humming sound. That's normal. That's indicating that it is taking some kind of a charge. So I would go up with this to power level number 3. But see, it's only going to 3.2 volts on the meter there. So we've already tested this battery. It doesn't work very well. Let's go over to another battery. Now this one we don't need the magnets for. Actually, before we do this one, let's go to this battery. It's a single C-cell battery. And this is a nickel metal hydrate battery, so we're looking at one of these C-cells, probably on power level number 2 would be good for this. So let's move this out of the way. And again, let's connect that up. So we're at 1 volt. So this battery needs to be charged. So let's go to battery charging level number 2. And right away it goes up to 1.5 volts. Now that's not a resting voltage, that's under charge. What this will do, as I said, it will go for a predetermined amount of time and then it will stop. And then it will check the voltage of the battery while it's not being charged. And if it sees it rise higher, then it will continue to charge until it sees it plateau. So if we turn this off, the battery under rest will lower a little bit. But we started off with 1 volt and now we're at 1.4 volts. It will take, obviously, or 1.3, it's coming down. It will take several, an hour or several hours to charge up a given battery, depending on the power level, intensity, and the size of the battery, the capacity of the battery, and how discharged it is. Initially with this charger, you have to understand that it's trying to rejuvenate the battery, it's trying to bring it back. So even if it's slightly used, it will take extra amount of time to work on the battery to bring it back to a usable condition. So let's go over to the next battery, and this one we do not need the magnets. We have terminals that we can clip to. So let's clip to these terminals and somehow put our voltmeter in. I'm not aware of whether this battery is off gas or not. This is a gel type of battery, and it's sealed, so it's a non-spillable rechargeable battery, valve regulated. So what that means is quite often these batteries are overcharged and they're off-gassed in a way that makes the battery unusable. So when that takes place, we can't really restore them. But if it's undercharged and merely sulfated inside, and then we can actually bring them back. So now this is a 6 volt 4.5 amp hour battery. So let's go over here. Power level number 3 at 6 volts 3 to 4 amp hour is indicated. So we're going to start by looking at the voltage. 0.2 volts. That's a bad sign. See, right now we see a flashing red light, probably because there's nothing we can do for this battery. But let's start by pushing the red button in. You notice now it's a solid red color and we have some voltage reading on here. As long as we bring it up over 1 volt, the battery charger will start charging. So I'm letting go right now, and right away it flashes, it goes down to 0.1 volts. This battery is not holding any kind of charge. So we'll try it again for a longer period of time, hopefully put some kind of charge into it to get it going. But usually when it goes down to that low voltage, it means there's some serious problems. In this case, when you have a battery that's been off-gassed, it's also overheated and the internal materials will have deformed, and so that there's no contact available inside for you to actually charge. Even if you were to add water into it, it would not help it in most cases. Sometimes people have been able to pry open the tops and fix them, but usually it's not worth it. So we got 4 volts while I'm holding this red button down, and I'm going to let go, and again, now it's actually holding 4 volts. So you can't hear a buzzing sound, so there's very little current going through. If we're going to change this over now to an ammeter, and we're going to look at one of the lines here, we're at 0.0. We're basically at almost nothing going into this battery. So that's a bad sign. It probably won't be able to take any kind of a charge. And notice that it's 4.1 volts. It appears that one cell is probably severely damaged, and that's why you don't see it registering 6 volts. 6.3 volts is what you see on a battery normally. That's a 6 volt battery. 1.2 volts per cell. Same thing with nickel metal hydride and nickel cadmium batteries. They're all 1.2 volt cells for rechargeable batteries. Now, I want to mention here before we go on, alkaline batteries that you find that they are 1.5 volts. They're different than these batteries, and they can be an inconvenience because sometimes devices require a higher voltage than these rechargeable batteries allow, so you have to use alkaline batteries. Now the good part about this technology is we often see batteries climb to a higher voltage than they usually do with conventional chargers, and that means you can approach your rechargeable batteries for those devices that require a higher voltage and alkaline batteries. People have often wanted to charge alkaline batteries, and we can't get into recommending that because it says do not charge, may explode, and that's a legal problem for us. We do have some batteries that we use on some of our products, our motor generator kits, for example, that have been used for 20 years and they've received some form of a charge. But generally, alkaline batteries don't receive much of a charge after they've been loaded down, especially if they've been loaded over a long period of time. If they've been loaded down hard over a short period of time, they can bounce back, they can receive some kind of a charge, but we don't really recommend that because it says do not charge on them. So let's look at this again. Even if I turn the power level up, you can see the voltage is climbing, but there's no buzzing sound in here. So there's very little power going through this. It's not able to make very much contact in here. But we do see 6.5 volts here on the meter. So if we were to turn this off, what would it do? It goes immediately down to 0.6 volts. It's a little bit higher than it was before, but now if I try to turn this on, it's going to blink because I need about a volt on here. So I'm going to hold this down and again let it go, and see now it is taking some kind of a charge. But you have to evaluate whether it's worth the time to work on a particular battery. These batteries can be very expensive. When you go to a child toy store, you can find these batteries for $50. It's very expensive. So sometimes it's worth it to spend the time on this. And this battery charger can pay for itself. Presently it retailed for $370 before shipping or taxes. Taxes are only included in Idaho. So let's go over to another battery here. Let's turn it off and then attempt to see what the voltage is on this battery. Alright, so this is a better battery. I bought this about a year ago for our experiments in our electric vehicle chargers that we're in the process of making. It's sitting at 12.2 volts on the voltmeter. And now we're going to look at the power levels here. This is a 12 amp hour battery. So at 12 volts, 12 amp hour battery could basically be turned to power level number 7 or 8. Now, if you go too far on these settings, what will happen is a circuit breaker at the back, where it says 3, will pop out. That will indicate that it's pushing the system too hard and it's protecting itself. So then you want to turn it down at least 1 notch. So it's better to start off lower and work your way up higher than the other way around. The other thing is too, you want to be careful with these batteries that you don't off-gas them. If you do hear sounds like bubbling inside excessively, or if it's going tss, then you will want to turn it down at least. Sometimes it's necessary to do that to bring back a battery, and so you sacrifice a little of the off-gassing for bringing it back. But in this case, I know these batteries are good, so I'm going to turn it on power level number 7. So we can see it's pushing it up to 12.9, 13 volts pretty quickly. So if I was to turn it up higher yet, oh no, that is number 8. We're already on the maximum power level. So really the maximum power level for lead acid batteries, 12 volts, would be this battery over here, which would be similar to this capacity here, 12 amp hours. This is an amp hour battery. It's not a starter battery, whereas that battery over here we looked at yesterday is a starter battery. And that's about the maximum size people really want to use this charger for. Several of our customers would like to use these for car batteries, and that's just a little too big. This is a gentler charger. It's not really meant for the really big batteries, and if you have the power level up too high, it will pop the circuit breaker on the back, indicating you're pushing it too hard. So if you're going to try and use this on larger batteries, like car batteries, it's going to take a long time to restore those batteries. We have the other charger, the RC-1AU more suited for those types of batteries, or the 10 amp charger, or the 24 amp hour charger, 24 amp charger for that. So again, we can charge a 12 amp hour battery on settings 7 or 8 here, and it will make a humming noise like this. See, as we go down, you can hear less and less. It's not pushing as much. You can see the voltage on here, 12.9, going up to 13 in a moment. So this charger is really a universal charger. It really covers all the ground. It doesn't do the very big batteries, but it covers all the small batteries. So let's look at another battery. Let's look at power tool battery. Let's say a little bit about this charger. Our customers are really happy, especially with these type of batteries here, which are nickel cadmium still mostly, and we've been able ourselves to restore here 20-year-old batteries, 25-year-old batteries, or however far back they go, and that's been really neat to see tools come back when they have never been able to, they haven't been able to be used for quite a long time. So let's try again. We got positive and negative here on the end of the battery. If you can't figure it out, the charger will generally not work until it's it will flash red, indicating an error if you have these terminals mixed up. The only problem that you may have is if it's down to 0, and then you have to push the red button at the back, and then you're trying to reverse charge the batteries. So you want to try and really figure out the polarity here. And if you have the old battery charger that it came with, you can plug it in and see with a voltmeter what voltage is coming out of each terminal with the voltmeter probes here, and then you can determine which one's positive and negative. But most of them are indicated, like this one as well. It's indicated on here, positive, negative. So this battery right now, before we hook it up, let's show you that it's completely flat. This is one of these old ones that self-discharge. That's the only problem, is that NiCad batteries, as they get older, will always self-discharge, even if you restore them with this charger. So if you don't use it, you lose it. So you pretty much want them charged the day that you're going to use it. If I can get this working here. So here again, we can see the clips attached to the magnets. Nice firm connection there. And now we're at a 14.4 volt tool. So if we look here, nickel cadmium, 14.4 nickel cadmium is different than 14.4 nickel metal hydrate. That's number 7, and nickel cadmium is number 6. So we're going to turn it down to number 6, and we're going to notice again the voltage. The voltage here is obviously going to be 0 or close to it. Well, actually, we're not. We're at 6.9. It's not bad. So this battery has more hope than there's more hope for this battery than other batteries that would be down to flat 0. So let's turn it on, and you can hear a faint but noticeable buzz on the charger, and now we're up to 18.6 volts. So we'll let that run for a little while, and we'll see if we can get anything out of this into this drill. All right, so another another power tool that we have here is 18 volt. So in this case, again, we have a whole bunch of different, four or five different connectors. And what these other connectors are for, in this case, there is actually no other purpose than the two ends. This one in here and this one on the end are the only ones. These other terminals, while they may provide power, they don't actually connect to anything here in the drill. So you can see very faintly the positive and negative symbols on there. And so with this one, you can't really get in there, so you'd have to create something to slide in there and connect up to with these terminals to be able to charge them with our charger. But you notice here it says NiCad. So these are fairly new batteries, so there's quite a bit of power in them already. What our charger will do for you, in the case of a brand new battery like this, will give you a little bit more power in that battery. So you'll start off with maybe a little bit higher voltage, and it will stay a little bit higher voltage. Like this graph over here, I'm going to show you. We have many graphs. So here would be a graph, for example, with the other charger, the RC-2A12, where the red line would be the leading brand, the amount of power you're starting at 13 volts, say on a 12 volt battery, and then ending off over this amount of time, minutes, 70 minutes, under a given load. And then our charger starting off at, say, 1330 volts and holding out over time much further. So what's significant in these graphs is not merely the beginning voltages and the higher, the more power here, but that it doesn't drop off. There's a lot of lower end as well as top end power increase. So if you can hold a drill battery out farther, even under, see in this case we have 12 volts represented here, and soon after 12.2 volts it just dropped down to, you know, that was its cutoff point before it really fell. If you ever watch batteries, they usually just have this drop off point where they just go right down to 0 or a few volts. But you can see ours is extended out way beyond that, and you can notice that on all of our chargers, these kinds of graphs. So let's take a look at this battery that's been charging for just a couple of minutes and see if there's any charge in it. First of all, let's look at the volts and see. It's resting at 16 volts. Of course, it's not charged by any means, but you have some real power there in a battery that was useless. So we're talking about a couple of minutes. There's some real power there, whereas you didn't have that before at all. So we can charge up, as I said, any type of battery. And let's talk about one more thing here, and that is our customers. Our customers have been using this, as I said earlier, for 5 years now, or almost 5 years, and we haven't had these fail. The only one that has failed, as far as I remember, was from an Amish customer of ours who kept the charger outside and he ran it off of an inverter. And who knows what else he did with it. He is a friend of mine. and there was one that failed because of whatever he was doing to it. But this is not meant to be run off of an inverter. It's meant to be plugged into the wall, pure sine wave from the grid power. We did not make this a portable charger. We do have other chargers that are more for that, like our solar chargers and that. But this particular charger requires a pure sine wave to work properly. If you use a modified sine wave, it will not charge properly. It may damage the unit, and it definitely will not give you the right kind of charging that you're after. So my point is that we have not had this machine fail. It's very well protected. It's made with quality parts, quality manufacturing, and it's one of our most popular chargers for sale. Customers have been really happy with it. So the other thing I want to mention too is that you can parallel or series batteries. We don't really recommend paralleling batteries up together, but say if this was a 12-volt battery and that it was a very similar capacity. You want to match your batteries together, but you could put two of these batteries together. I don't have another battery around here, but if we had two of these batteries together, we could do 24 volts here, because this is a 12-volt battery. This goes up to 24 volts. Now with these, as long as these were 9 volts or 12 volts, you could do the same thing. You could connect another wire from the negative to the positive of the next one, and then put the clips on either side. So that's what you could do. This is again is a 6 volt, so we could have 4 of these in series. Again, the difference between series is going from positive to negative, positive to negative. Parallel would be putting all the positives together and all the negatives together. And we don't want to do that. The reason why we don't want to do that is because if there is a weaker cell, what will happen is when they're placed together in series, all the energy will rush from the one battery to the other, and it's not proper for the battery to be balanced out that way. And also, when you are attempting to charge that battery, all the power will go into the stronger cells, and the weaker cells won't receive the charge that they need. So you always want to charge a battery in series when you're rejuvenating it. Now say you got the batteries to all equal out, then you could attempt to charge them in parallel with each other, or if you start off with brand new batteries. But as soon as you have some age on a battery, you may find that have been charged with conventional chargers, you will find that they will be unequal, and so it's not wise to do that. So one more thing we should say again is, so let me say again that we should not use this charger outside. We don't want to have it in the rain or exposed to a lot of humidity. It's not meant to get wet. It's meant to be used indoors. If you read the owner's manual, we cover all the details. There's a 1-year limited warranty on it, and the manual covers all the safety instructions in here that you'll find in most battery charger manuals. Again, you're supposed to use glasses when you use batteries, when you handle batteries, rubber gloves, protecting your face and whatever, just to use some common sense with regards to batteries. I'm not going to get into those details because they're already in the manual, and that manual is posted online on our website. So the main thing is to understand that this is not a regular charger. So usually when you think of a battery charger, every cycle that you give it, a cycle being a charging up of the battery and then loading it down. So every time you cycle the battery, you lose time with a conventional battery charger and a battery. So the idea with this charger is that you can gain time many times, many cases. You can restore useless batteries and you can keep your batteries at least for a longer period of time. So what we often do is cycle a battery to bring it back, which, as I said, seems backwards, because normally you think of losing time every time you cycle a battery. But especially the lead acid type need to be cycled usually several times. That means charged up and loaded down with a suitable load. Don't load them down too fast. Don't go beyond the battery manufacturer's recommendations. These type of sealed batteries should be run at the C20 rate of discharge. That means this 12 amp hour battery shouldn't be discharged quicker than a 2 amp load is pretty hard on the battery itself. Maybe a 1 amp load. A 1 amp load would be like an automotive bulb that you might find, an incandescent bulb that you might find in your brake light. And that would be a typical 1 amp load that you could put on this to draw it down and then charge it back up. So between 3 and 5 cycles, you may find that the batteries that were useless come back significantly, if not 100% or even beyond 100%. We've quite often seen that, both in starter batteries for lead acid, like we have the Lawn and Garden battery over there, or in sealed batteries, or amp hour batteries is what I'm trying to say. And again, we can charge up every different type of battery. This product is made in the USA, here in Idaho. It is made with quality parts, and we hope that we can provide quality service to our customers. Thank you. Remember, with Renaissance, going green saves you money.